share is stay safe as usual, and OpenStack has its own updates. I have the link there. You can go through it. There is enough material, I know, but the essence of it is stay safe, keep distance. And yesterday we heard from the speakers as what is going to change in future, and that's from the what you call point of view of how things are changing, evolving. And I thank first thing I must say that IEEE Bangalore has been a very good uh, timing they have for this, and I believe this is one of the times when we can think a lot more philosophically as well as technically. And OpenStack is one of those four opens. And so I would like to start with that we pray for everybody, those who have been impacted, and this would be a good opportunity. This would be a good opportunity for us to
பேரும் அந்த சைடு
throw out
போங்க.
whatever we can do um, to help overcome the difficult position right now we are in, especially all over the globe. The number of deaths have really been very high, especially US has one of the major ones. One third of the deaths have been in US. More than 3 million have been impacted by this. So first we start with a prayer to them, and then I'll move on into OpenStack and containers in hybrid cloud. So question answer we'll take at the end. Of course, you can note down and so that we are able to do it
That's right,
systematic way.
Prakash. We will be addressing the questions at end. We would be reading it out for you. And I request.
Yeah, first another thing I would like to thank the CCICI for their uh, having been able to provide some documents for the Indian community and Indian nation, India as a nation. So acknowledgement to Pamela, Dr. Pamela and Dinkar and the whole team of people. So with that, let me kick into the gear and go slide by slide systematically so that you understand where we are right now. So what is the current state and what is going to be the future state in between what we are going to see. So this is, I'm picking up the OpenStack architecture just from 2019-01. Okay, it has been evolving. So it is 10 years and more than 20 releases every 6 months cadence. One release comes in. It started as simple two modules, two integrated modules from NASA. One, the object storage called Swift, and the other one called compute called Noah. And all these were bundled into those two pieces to start with. It was an integrated OpenStack to start with. Eventually, as we moved, I'm seeing 2019-01, I'm showing the architecture. So at that level, so it has been evolving, and one by one, we can see that bundling and unbundling has been happening of different modules. And what are those modules? What is external and what is internal? To start with, OpenStack is an infrastructure as a service. So it has to deal with the infrastructure. Therefore, how you combine the hardware to make a server and how do you use it? That's the key question. So infrastructure, currently everybody wants to see bare metal, and initially they used to want containers run over bare metal. Sorry, virtual machines over the bare metal with the operating system, either with a hypervisor being a para-virtualized or a KVM or a native. And then eventually that virtual layer which used to support the guest operating system has been going down in the sense that containers are directly being used over the bare metal to get the optimum performance. So you see infrastructure as a service with a shared networking and shared resource with a bare metal virtual machine and container. Obviously, networking is important to connect, link between everything, and then a stack of software which runs on top of it. So the OpenStack is the stack of software which runs over these uh, infrastructure, and that have APIs associated with application programming interface, what we call, so that each of the services can be run. So we'll take a service view of it later. To start with, where do you use the stack? So cloud, when we say cloud, we used to, when we started 10 years back, we used to have VMs and we used to say, hey, VMware is the VM. Everything is about VMware. That was called as uh, bottom up. So you take the hardware, you build it, and you can run the VMs. But then when OpenStack came in, there were competitors like CloudStack and other things. Everything wanted top down. So the top down, when I mean, is you take the APIs, and those were called cloud APIs. So so cloud OpenStack started the cloud API as the way to go and succeeded in uh, overcoming other competition for reasons very well clear that it went top down, you could do bottom up as well as top down. That was the early days of 2013's type when it was in the release. I would put it as F release or G release. Grizzly is when it actually changed the stance from being a integrated to getting vertical APIs separated out. But overall, the reason was enterprises wanted distributed OpenStack because you have multiple units to govern, and governments of the world also wanted. So you can see that enterprise software was the first. It was used as a private cloud. It started with private cloud because at that time Amazon AWS was the top gun. Even now it is the top gun. The APIs were compatibility maintained so that Amazon API was actually borrowed and OpenStack started with that. But later on it changed whether to maintain compatibility or not. That's where the whole thing came in because a lot of problems come. Uh, Maintaining compatibility is not easy. So in some in between, there was a in 3, 4, 5 years back, there was some uh, discussions and brainstorming, and finally it was decided that we don't need to continue, but eventually we still continue. In between, there was some discussions, but so the usage of cloud is the important cloud software. OpenStack is a cloud software. Usage of it for enterprise, telco providers like NFV came in between, and then you have on-prem for small medium businesses which need an integrated version. So you can view of OpenStack as a cloud software which can be run integrated, as well as you can think of it as being running as a microservices, which is the current terminology for single object focus or single function focus. Now, this can be deployed, as I said, on bare metal, virtual machine, and containers. We'll go through that as we go. So APIs are RESTful. That means you can, whatever we call in terms of CLI, create, read, update, delete. Same way you got the post, get, and put kinds of RESTful API, which is what we call. Currently, the Python 3.6 to 3.8 is what is used for CLI. 2.7 is being phased out. Still, it is part of the Swift. So you can go to the reference here, openstack.org/software to get the details. Moving to next. So now we have to look at what is the generalized OpenStack module. There are many modules. So what are the modules? What is the client? What is the API? So if you look at the client is generally OpenStack, uses OpenStack library object called Oslo library, and client is a usually a Python. It does support others, but mainly it is Python. And Python 2.7 was till last release. The current release is the Usuri release in progress. And this time, mostly it will be 3.6 to 3.7. And some of the features are there in 2.7 because of the Swift. So I'll come to say what is Swift. So from perspective of a client, either you have command line interface where you can use the command line to execute the API, or you can directly go through the endpoint called the URI or URL. And there are several objects APIs are supported. So I have just listed 15 of them, just 15, because there are more than 40, 45. So you need to identify a user ID, whether they are an administrator or a member to just a user. Then you have the endpoint, which is the URL or URI where you can use the API to call. Then you have got image catalog, which is called clans, which is containing the image pointers, and storage will be will be Cinder, which is a storage. So compute is generally referred as Noah. Network is referred as Neutron. Object storage is referred as Swift. Block storage is referred as Cinder. File storage is referred as, many of them are there. So I'll leave that, because you can have NFS also as an option. You can have uh, other. Um, then you got application catalog like Murano. Containers you got like, many of them are there for orchestration and for container API like Zune. We'll discuss that later. Coming to bare metal, you can use it. DNS and orchestrations are two key pieces. In DNS in OpenStack is called designate. Orchestration, multiple orchestration are there, but the main one is heat. And then competition
Prakash,
for that is Kubernetes. Yep.
sorry to interrupt. I think some of our friends are not able to see the screen, but it is working fine for me and some of the people here in Bangalore. Could you just
Mhm.
unshare and share it again?
Yep, I'll do that.
Yeah,
Let me see. So I have to stop sharing. Okay.
yeah, that's right. Yeah,
And then I can reshare it.
right. Yeah, it's coming up. So I can see your slide. So you need to go to the slideshow
Okay.
mode.
So I was talking about the APIs, and DNS is designate, orchestration is heat. There is a competition, of course, and that is the Kubernetes for orchestration. However, it is already embodied or embedded into OpenStack through Magnum. Magnum can drive orchestration through Kubernetes. So you can still integrate. Security, Barbican is there, and there are many others for especially API level, as well as the, what you call, the security with the SSH keys and all that. Messaging, you got a RabbitMQ, and dashboard, you got Horizon. So what I mean is, I have listed basically APIs for primary objects, and usually there are two aspects. One is the data persistent storage, or the persistent storage for the system. You consider OpenStack as a system, then you need to manage the system related data and metadata to persist, and usually they need to be scalable. So conductor is the piece which is common across, and you will find metadata servers associated with them. And usually for most of the time we use MySQL as the data because it is open sourced as part of the release, and that is where the data is stored. Now, storage is complex, but I will leave it that Swift is one of the object storage for distributed. So if you have multiple nodes and multiple bare metal and where a server is being created, When I say server, it always means you can conceptually take it as a VM or a container. Both can be instantiated over a bare metal. Even the other way around, a container can be installed inside a VM and over a bare metal. Now the concept of pods is different here. In Kubernetes, pod is the unit which is containing the containers, and pods can stateless they can be destroyed and created and recreated, and so that you can manage well. Here the concept is you have API level, that is, if you take one Noah, then I'll be dealing with Noah only, all compute related. When I take Neutron, I'll be dealing with. So the distribution already has taken place of the data associated with the system within that particular API. So, and what is this? So conductor can is used for scaling. And when it comes to MQ, RabbitMQ is one of them. You can replace with any other MQ you want. But it's a asynchronous message queuing where you create a topic, and that topic can be pub sub. That is, you can publish and subscribe to it and use it. And that's what the API do. So API for Noah will have a Noah topic with a read or a write or create, read, update, delete, whatever topic you have. And so the writes and reads are separated out for scaling. So this is very important, and that makes it that the two pieces which are required for every API is the data, metadata, data associated with it, which is scalable, which is distributable, and same way the topics they work with are able to connect and publish and subscribe over distributed servers or the distributed network. So this is some of the thing, and hypervisor software. Early, it started with Zen. It started supporting ESXi, and then eventually it moved on to support most of the libvirt. So everything was captured into libvirt library, and most of these days, virt.io, and those are the various concepts. And so I will go to the next one. I think, no, before I go, yeah, here is the objects for computer and networking. So let me just run through one quick pass. We are into 15, more than 15 minutes we covered. Let me just go through object. So you have network. Object is the key because we have not discussed about network. Everybody thinks of server first, but networking is computing, as we have been hearing from long time, from Sun days, Sun Microsystem days. So if I say network, then we have to have an ID. It is segmented, and once you segment it, that means you have partitioned it. Then you have got a port ID, which is a logical port. Trunk is combinations of the ports. Then you have the scope of the address, which could be IPv4, v6. Then you have to be able to route them. And when I say CRUD means create, read, update, delete. And the type can be L1, L2, L3, L. This is the OSI layer. So L1 is physical, L2 is a link layer or MAC layer, and L3 is the routing layer. So what happens is you have to have an interface, and when you have an interface to a router, then you associate the subnet and the ports with them, and so that you can connect to the IP within the subnet or within with the ports assigned, so that you can run uh, what you call listener concept of listening and forwarding and all that. So you also have a flavor. Flavor is to add to the neutron or the networking object the service type. So if you want a firewall, you can have a flavor for it. If you want a load balancer, you can have a flavor for it. And obviously security is important. So on a given port or a IP, whether you want certain thing to be allowed or not allowed the traffic, that is the security group. So this sums up the network API. So there are two part to it. We are always talking here of virtual network. So where is the physical network? Physical network is done separately, and that is why the bare metal and the segment ID is the one where they call it phi, physical is associated. So when you have a network, you have a physical network, you associate the segment ID, and then you have a ID associated with that, which can be trunked with ports and address and all that. And then the virtual network uh, takes over so that you can have a virtual network on which you can install the VMs. So let's come to the server object. So you create server with the images, and obviously there is a flavor associated there also. The two flavors are different. The flavor for compute is the combination of what size you want, and obviously they have to be connected. Server and network and computing cannot go separate. They have to meet at a point, and that is where they meet at in servers. They meet at the NIC level or the network interface card, and then on that you divide that into multiple what you call segments or multiple pipes, and those pipes have to be funneled into the VM if you are using VM, or into container if you are using container. So the server has different action. You can start, stop, resize, add. Um, you can add floating IP so that it can be externally accessed using those floating IP which are public IP, whereas when they are created, they have a private IP. So that's the IPv4, and IPv6 is you don't have to worry about it because you got the scope, and the scope can be whether it is local or it is global, and so those addresses those part of it. And this is supported both IPv4 and this is dual stack is supported. You have got servers, you got admin actions like whether you want to inject a networking info, whether you want to migrate a particular um, OS with the server, or you want to evacuate, you want to reset things. So server has obviously address, which is used as a IP address, and then you got metadata associated with servers, which are like security group to associate what network it is going to allow or deny and use, what ports on the server NICs are going to be used, etc., etc. So server also you can have OS interface where you can provide the network IP and the port ID associated with them. Servers can also be interface. So server OS interface is the uh, networking, and server OS volume is for the storage. So you can attach, detach a volume, etc. So you can see that the whole picture is objects of compute and networking are the major. I have the API reference here listed, and you can go with APIs. This is only two API I have taken. You have got 15 to 40 modules approximately. Half of them are retired, half of them are. So it's evolution. So I would say if you know 20 APIs, that is big enough. And whenever you want, you can always refer to it. So let me go with the OpenStack ecosystem for 2019 01.
So Prakash, sorry to interrupt
Mhm,
again.
mhm.
So like there are complaints saying that most of them are not able to see the screen. So can we share the slide decks from our end so that you can speak over it and take over the session ahead? So
Sure.
probably if you can stop sharing,
So
we will share it from.
I can stop sharing, no
Yeah.
problem. Yeah, you have the,
Yes, yes.
uh,
You have shared
okay.
it, the slides, so we will be sharing it.
So you want to share from your end, or what do you want to
Yes,
do?
we will do it.
Yeah, go ahead.
Yeah. So probably, Punit sir, can you make me the presenter?
Is everybody able to see it now?
I hope the people can see it now. Yes, Prakash, we can continue. I would go on
Yeah.
to the next
Next
slide.
slide. Next slide. So here is the OpenStack modules and ecosystem as I have 2019-01. I'm taking 2019 because that's the place where we started moving out towards disintegrated our API version, microservice API and all that. But a integrated view you have to look at first before you can get disintegrated view. So the integrated view is you have got different modules and Keystone and Glance. So you can see core modules are in the dark here. So you look at it, Ionic has become one of the core because you have to have a first bare metal to install any OS, boot any OS. And our boot OS are boot in the using RAM disk, any of the uh, para virtualized offerings. Could be Zen, could be ESXi, or you have canonical Ubuntu, and then you got Red Hat, OpenStack. And so initially you need to have something installed, and that is the Ionic piece, which is the metal, touches the metal. Then once you are done it, then first thing to come is, hey, how do I get access? Where is the endpoint? So the keystone is required. And to build keystone, the base minimum requirement is you must have the RabbitMQ, message queue, and you need to have MySQL. So those are the first two to come in. And if you use DevStack is a developer's version of OpenStack that is usually used by everybody. You can install straight away in your notebook or somewhere in the cloud. You can go with the RabbitMQ and messaging queue, and then comes the Keystone. Keystone has all the endpoints, API access, and all that, and plus the whether you are administrator, whether you are a member, etc. Are you facing audio problem? Do you want me to speak louder? I hope not. Okay.
We are able to hear you loud and clear, Prakash. You
Okay.
can continue. Yeah.
Yeah. So you can have then the placement of the compute. So that is the Noah and Neutron are the key pieces there. Then Cinder is another one for block storage and Swift. So heat is the orchestration mechanism. So you will find that you need heat and you need a DHCP. So Neutron generally does all the DHCP services, L2, L3, various services it provides for networking. So all networking services are embedded in Neutron, and it can be a plugin. You can plug in and plug out whatever you want, depending on what is your requirement. And so you see the dashboard is the Horizon, and supported API is EC2 and Horizon. That means what is this? AWS EC2 is still supported, and you can have workloads which are different. Like examples of workloads is normal workloads are what you talk about compute workloads. So here is a compute I have. Yeah, I'm running in a distributed what do you call a architecture where eventual consistency is maintained through the Swift, so that you can anytime ensure that you will reach some consistent state to be able to use. And the container orchestration engine is so one of them, which is Magnum for workload. Database as services is another. Tro is there. Data services, Sahara is there. So what I mean is the whole system of OpenStack is divided into networking, hardware related, storage related, and shared services, which are at the bottom you can see. So you have shared services over which you build the networking hardware and storage, and then use the compute to run them. And compute, you can see Nova is the one. Nova compute is for the standard usage, which is your VMs, OpenStack VMs. Zune is for containers, and you have got what do you call? Uh, sorry, Quilling. Can you? Am I able to see the screen? Yeah. So Quinling is the one which is used for functions as a service. So you can see on the side there are operations for operation and monitoring tools are there. Your optimization, those are various additional tools. Congress used to be policy, but people may not use them. They can put their own Like if they want Prometheus example from outside, they can plug in. So monitoring here's Munaska is for the time series, then you have Panko, and so there are plenty of them on the operation side of it. And on the SDK side is the Python SDK, which is the most famous one or mostly used one, Oslo library. There are Go library getting introduced into open infrastructure part of it, but at this time I'll leave that. Courier is the one which is used for the container networking, so that you are able to use container network along with and Tacker is the one which is for NFV. Now, each one is in different state of affairs. I wouldn't say that every module is used by everybody. Half the people, even the experts of experts, don't know 50% to 60% of it, because that is what the reality is. There are too many components and too many wide usage, and therefore it is definitely a difficult task to configure, but automation has come in. So next slide.
Can I ask the participants to go on mute,
So
please? Hello. Hello. Can I ask the participants to go on mute?
heat, heat is the major orchestrator. Even the Magnum, the container orchestration engine uses heat. Heat is made of, you got templates, heat orchestration template, and the resources are described in the template. So that is called uh, descriptive way of rendering the entire cloud infrastructure. So you compose the heat template with modules, and then you create the stack. When you create the stack, you are able to get the software stack running on a master controller, which we saw earlier, and compute nodes are the ones where you put the workloads, and that can be compute intensive, it can be network intensive. How you want to manage them is all flexible, and that is all done through orchestration. So orchestration is key piece, and heat is the key orchestration mechanism in OpenStack. And for automation, because the configurations are difficult, if I had to go into each one of them, etc config and etc nova, etc, and there are so many Linux file system level configurations that it is very complex. So the Ansible is one of the pieces. Heat and Ansible are the two which allow us to configure, and including you can use Docker container, you can use the VM, you can use the CRI, or what you call CRIO types, which are Kubernetes related. So you can have containers of different type. Next slide. So this brings me to the next topic. After heat, what do we have? We have, besides heat, designate, and you can see at the bottom here, designate and neutron working with heat, with the glance and cinders to provide a OpenStack compute nodes. So what I am going to do is, we are talking of cloud. When we say cloud in OpenStack, a stack is a cloud. So you have heat created stack, which can be created in multiple locations or multiple distributed way, distributed nodes. So if you have compute nodes distributed across, what do you use it for? You can use it for some purpose. So one of the purposes is, in this case, data services. So Sahara is the implementation of Hadoop. So got a Hadoop vendor can use, like Apache Spark or a Storm can be installed over OpenStack. So OpenStack compute nodes is the one which is scalable, that provides the distribution. So you can use Sahara along with those in the OpenStack compute to be able to use as a data service cloud, or you can say streaming cloud. So the integration here, different players provide different way of doing, like Cloudera. They can use this as a OpenStack as a base for it, and then install the data service. So now what has happened? from a single purpose cloud where the idea was just to do infrastructure as a service, it has become a multi-cloud in the sense the purposes are different now. Different functions can be implemented. So one of them is data services, which is Sahara for the big data, whatever you want to use, HDFS and all that. And streaming, example, Spark, Storm. So there are distributions which are distributed by various uh, vendors who leverage on the OpenStack compute. Next slide. So here is another application like Murano, which is an application catalog. So you can see the components, various components being stitched together using Keystone and Heat, and Murano is the API. So Murano API runs over VMs, or you can do it under containers also, but this is a application catalog. So you can see that when we talk about cloud with different functionality being used as part of the infrastructure as a service, that becomes multi-cloud, but they are function per function, one function per cloud. So you can have one cloud which is in a company, you may have multiple departments. One may be dealing with data services analytics that could be implemented as a compute workload. Then you can have application catalog where you can show the various availability. Example, if it's an educational organization, it would like to do the um, catalog of all the people. If it is a government, it would like to provide all the catalog of all the services it can provide. So the here the concept is you are running from infrastructure as a service. On top of it, you are running multiple functions or multiple clouds, but they are all at this time homogeneous in the sense that we are only talking of OpenStack with multiple clouds of OpenStack. Next slide. From this, I will dive into concept of what is, before I get to the concept of uh, hybrid cloud, let me bring in the viewpoint of containers before I jump into it. So the viewpoint of containers in OpenStack is you got a bare metal and you got the servers and you got all the services. Ionic is the one which spins the bare metal and provides you the ability to configure the bare metal. And now you can install Kubernetes on it as a cluster, and you can run containerized OpenStack on top of it. So this is a new concept. Currently it is not part of the OpenStack, but open infrastructure. But open infrastructure is one where example is a airship. AT&T uses that. What does it do? It takes the undercloud. So there is a concept of undercloud and overcloud. Undercloud is based on the physical networking and physical everything. Whereas virtualized, you run on top of it. Same thing with Triplo. There is a project called Triplo for Red Hat, which does the undercloud. And then you have got a concept of overcloud where you have got the, if you are a Kubernetes, you will call it pod networking. If you are OpenStack, then you will call it container networking. So basically it's a networking. And if you are using like AT&T, they use Calico, which is a layer 3 version. So between the layer 2 and layer 3 in Neutron, usually you have plugins which allow you to build the what you call the integration pieces. And for containers, since the containers, when we talk, that's nothing but a packages which can be run using they are immutable pieces which is built around images, and then you have a container package which can run as an instance. Example in Linux itself is LXI. So you can have a native Linux container, or you can have additional containers like Dockers or Rocket, or there are many containers. You can Core OS. So you can build containers with different, but most of them have an API. You have to create a container, you have to create a cluster of them, you have to manage the cluster. So Zune is the piece which is the API level. Magnum is the container orchestration engine, and you can see you can build on top of it. So you can see the two pieces: infrastructure, bare metal infrastructure, and cloud. Cloud can contain containers, and usually the containers, infrastructure containers are the key because they deal with the hardware directly. So since they deal with the hardware, they have to deal with the CPUs, the GPUs, and FPGAs. So infrastructure containers are different from application containers don't want to deal with the hardware. They want to be independent of, so that they can be portable for application. So that's the application container concept. So infrastructure containers generally are hardware centric, which is what is the key piece for infrastructure as a service OpenStack. On top of it, you can build the application containers also over the bare metal or over within the VM. Now, there is a third part of it, which is like you want the containers to be secure. So there is another concept called new infrastructure services called Kata, which is a container which is secure, which is a in between. It's called a lightweight VM or a container. So it's in between the two. So these are the concepts from the point of view of containers. Next slide. Now I will get into the types of containers. You can see here, this is a table which gives you different container types. And the mark in this, the cola. Cola is the one which creates the images. It can be used using Ansible, and it can be used with Kubernetes and Helm. Helm is a packaging tool like your Yum or a apt-get, which you use in your Ubuntu or on a what you call SUSE or a Red Hat or whatever your Linux distro is there. Helm is for packaging, and usually this is where the Kubernetes and OpenStack come together. So you can see that there are different projects running in Magnum, Zun, Quinling, Courier, Kula. These are some of the things we need to know, and most of them are compliant with standards like CNI, CR, Cryo. This is container networking interface, container runtime interface, and CSI, container storage interface. So all these are uh, capabilities that are projected. Next slide. So with this, I come to the OpenStack interoperability, because before I go to hybrid cloud, multi-cloud capability, now you can run a OpenStack installation as a distribution, like you see Red Hat distribution or for a canonical distribution, SUSE distribution. So they can be as an appliance, they can be sold by the vendors, or they can be in the public. So the same OpenStack like Rackspace is a public cloud. So you can create a public cloud, then you can have hosted private cloud or a public cloud, and then you can remotely manage them. Then you got training example, you got what do you call our uh, CDOT. CDOT has a training portal which is OpenStack compatible, and they have the logo mark. So OpenStack provides a way of uh, ensuring that you have the capability. There are two aspects: capability and compatibility. Capability ensures that you have the necessary requirement to be able to scale, auto scale, auto do a lot of things, horizontal, vertical, and all those which are API driven. So there are something like 80 APIs which are identified as common, and you can see there is a ref stack. Yeah. So yeah, I'll close it fast. So you got different way of different distributions of appliance, public and private cloud, as well as you have capability which are hardware and software integrated in or disaggregated. So those are available, and drivers are there for each of them. Need to be ensure that every driver that is used is uh, meeting the requirements of the API top down. Next slide. So this is the marketplace, uh, how OpenStack has been able to provide the market for, because all open is good, but somebody has to make money out of it. If somebody doesn't make money, it doesn't really uh, work out, because a lot of vendors support because they make money out of it, and they have a commonality which is what is provided by in terms of capability. So you can see that OpenStack interface interoperability currently covers some of the things, not all of the things. So compute it covers, storage, Swift it covers, and combination of storage and as a platform it covers. So these are the three. Still, they are not covering the GPU, GPGPU, NVMe, and all those. And we expect that over a period of time, this will evolve. So at this time, 80 plus 20, 100 APIs is more than enough to govern the interoperability. And there is an interoperability test that can be run directly over the portal. All you need to do is it all is user level, no admin level. Usually admin level APIs are not tested for interoperability. You avoid that because every administration has a different way of, as long as you can interoperate between one stack or one cloud and another stack and another cloud, that should be the only criteria. So this is what we are showing. Next slide. So multi-cloud is only supported currently. OpenStack only supports for API level for multi-cloud. But when I say multi-cloud, it does not include hybrid cloud. In this case, you got hybrid cloud. So you got a Google cloud, you got a AWS cloud, Azure cloud, OpenStack cloud, Kubernetes along, Kubernetes container run, OpenStack run. So infrastructure level is either you take OpenStack or you take a Kubernetes cluster. Those are the two standards, industry standards now. De facto, you can say whether we like it or not, that's the people like to have. And based on that, you can have a containerized version of Google Cloud, or you can have a containerized version of OpenStack also. So a containerized version of Azure, containerized of AWS, you can have. So capability is one thing, but comp compatibility is the one which is required for hybrid cloud. So if I take a workload, a move from one cloud to another cloud, or if I have to have aggregation of services from multiple and combine them, or uh, a simple example will be if you have an enterprise and it has got multiple branches, then each branch has a cloud they use and they are of different type. One uses like accounting, maybe using um, something which is related to OpenStack, and the other cloud example, they may be using something related to services like support services and our sales services. They may be using a different cloud. So how they run in different clouds, but yet be able to interoperate with each other, that is based on the compatibility. So capability wise, you do have for multi-cloud, but for hybrid cloud, there are no current standards. Not that there are not standards, but the question is that um achievable? So most of the achievability has come that because you can do everything containerized. So for hybrid cloud, containers are a easier vehicle to manage, and therefore, as long as you are able to do workloads to be distributed in containers, it is easy to do it because container is isolated and they are packaged and they can be easily be dragged and dropped anywhere or for that matter moved across. So hybrid cloud is more going to be based on uh, containerized workloads rather than the VM, which gets stuck to the hardware in a way because of the dependencies. But even there, if you are going to use infrastructure container, that may not work. Application container is the one which will allow us to do the interoperability. So these are some of the various, like cloud bursting is one applications which allows hybrid cloud to transfer the load from one cloud to another cloud. So enterprise may have in a private cloud within the company, and then outside they may be offloading it for a peak workload to some cloud like Azure, could be Google, could be Amazon, could be any other. So that's why you extend the OpenStack cloud using public clouds. And not only that, it also depends, right? You can today everything is in x86, tomorrow it may be in ARM, tomorrow, day after it may be in RISC. So you don't know architecture, how compute architectures are evolving. For high performance computing, it may be different. Next slide. So this is what I see. You can see high performance computing is another one. There are various schedulers required, like you got the Slum, PBS, function as service, and then you got high performance computing, Cobalt. So there are various high performance they require scheduling, they require. So X days, X means earlier 2010s time, grid was very popular because it was job oriented, and that was the time when Hadoop was taking off. And so you can see those time it was grid, but grid evolved into a different thing today. Today, grid is coming back, but in a different form. So you see, high performance computing requires a lot of compute capability, multi processor, multi GPUs, and so you got thousands and thousands of cores running rather than just 40 and 30 and hundreds of cores. So it's a compute intensive work in high performance, and therefore the serverless concept has also taken, because function as a service you bring in into the. So we can bring lot of various ways to achieve, but containers is the way to achieve hybrid cloud workload interoperability, and this needs to be extended, and therefore containers is one way. Application containers in specific, because they are immutable, you just have to throw in and throw out. The question comes to, how do you manage the state? Stateless is easy, but with state it is uh, difficult, but eventual consistency is the way to go, because if you do eventual consistency, then you know that you will reach the state, and therefore uh, hybrid and high performance when distributed cloud with the edge, because edge is again another area where a lot of people want services at specific places in the industry across the core, the 5G, which is talking about the radio unit and the baseband unit, and you got the front hall, then you got the data centers in the front hall, as well as you got the core, which is the place where you got the orchestration for packet gateway, serving gateway, and then you got the IMS of these worlds where you have the data networks where you run the data centers. Like if you have a Facebook, or if you are a Google, you can run your data centers in the IMS space, which is difficult to access. So there are many uses. So I'll go to the next slide and probably try to close here for question and answers. So one thing is OpenStack has been a journey, and in 10 years, what it has achieved and motivated others to do, including what Google has done through Kubernetes. All of this is learning lessons, and OpenStack has been a key to it. Next slide. And with that, I think, yeah, go ahead with the next slide so that we can start the Q&A. And thanks to IEEE Bangalore chapter for providing me the platform to do all the. And most importantly, I want to say that open is important for the globe. Open source, open design, open development, open community, and open technology, and uh, open infrastructure. And IEEE has been a very excellent platform for us to share in this COVID-19 and post-COVID-19 world. Thank you very much. You can start the questions now.
Thank you, Prakash, for an insightful session on the components of OpenStack and the functioning of OpenStack and how relevant it is in this 5G days. So we have some questions and we would be taking them one by one.
Mhm.
So the first question is, are there any security issues in OpenStack, or how secure is OpenStack for my usage?
Okay, OpenStack per se, there is a security group which provides the security, and then there are multiple layers of security. API level security, which is comes through the Kubernetes, Keystone. So you have the access tokens available there. You can program the API to expire as early as you want, 24 hours, 10 hours, 12 hours. So APIs can be through API you can manage because all the access is through API. The other is obviously servers need to be secured, so you need to use what do you call some kind of a uh, PKI infrastructure type of security, and there are modules for that, Barbican. So there are different layers of security. It is definitely secure. There are no questions about availability of. Plus, you can do encryption, decryption. You do tunneling, so you can even support the data privacy security of that type. So different levels of securities are spread across different areas, and fairly safe to say there are industry over industry where there are use cases all over the globe. Either it is a telecom area or whether it is a high performance computing like um, what we see in Europe. And so plenty of security is there. You have to pick and choose what you want to do. So that's the exercise, which is a bit difficult unless you are a what do you call expert in security. It would be difficult to answer. But my simple answer, there is availability of proof of that it has been secure very well throughout the world, whether it's a public cloud like you have Wix hosting or you have Rackspace hosting or Rackscale hosting and other OpenStack users of this.
Thank you, Prakash. In fact, that was really a nice answer to that. So the next question is, if I were using a language that will build a native application, say Rust or C++, what target it would build for? Would there be any specific compiler for getting better performance?
So this question is more to do with the optimization, compile, whether you do how do you do build, how do you bind, how do you make. So these are application centric. So
Right,
when you talk about applications, compilers are available. If you tie the compilers to the hardware, native hardware, then obviously you'll have to do uh, live with the portability being going down. That you have to accept. So if you are optimizing for performance, then if you go and use, example, if I give you a VTune as a uh, way of debugging, then that is the Intel compiler. And primitives are all embedded for late binding, early binding. Late binding is preferable dynamically so that you can uh, leverage C++ or Rust. Or there are versions of C++ going from 90 to 98, I think. So it depends on which layer, what are you trying to optimize. If you are going to use something more like a GPU, then you have a host device, and then you have the device itself, which is a GPU or GPU, or and if you are using a what you call a NVIDIA GPU, then you need to use their library, CUDA library. So the amount of parallel processing decides the optimization, and therefore the cores matter, therefore the GPUs matter, and also depends on whether you are compute intensive or whether you are network intensive. So you may use an NPU for network processing. So the application in itself uh, can be portable only if you try to hide the hardware centricity through the APIs. So it depends on what APIs you will be using. So there are many ways of optimization, whether you do it in the make build or you do the compiler, different compilers, what compilers you use, how do you manage the symbol tables. And so those are aspects which are more system centric. So language independence is important for application. But for OpenStack, when we are talking about open, we try to use Python here. So does that answer your question? I'm not sure, but I've tried my best.
Yeah, thank you, Prakash. So the next question is more on the deployment scenarios and using K8s for managing the workloads on OpenStack. So the question goes like, how do we set up the development QA and production environment using Docker or container and orchestration K8s in the multi-cloud environment?
So when you say K8s, you mean Kubernetes, right?
That's right. Yeah.
Correct. So how do you set up development environment? Simple. Dev stack is a stack. You take a dev stack and you install in one day, even not even one day, half a day if you have everything ready. So you need a hardware. You can use the you can use the dev stack to install the implementation of a simple OpenStack. Now this is pure OpenStack. But when you say Docker container, so basically you are looking at, can I do a containerized version of OpenStack? Definitely. You don't have to do physical, you can do containerized. So how do you do containerized? So there is a cluster API available in Kubernetes and there is a provider. And OpenStack is a provider, you can install OpenStack. So bring your own Kubernetes. You can install a Kubernetes cluster and then have the images which are there in the um, example Red Hat Quay.io catalog. You can pull whatever you want, the versions of CentOS or Ubuntu or something, and have the images for each of them. Like I have image for Nova, I have image for Neutron. I have so and then instantiate those Dockerized or Docker-based containers. Now you can use a Swarm as your catalog and bring from Swarm, or you can use the Kubernetes um, catalog, or you can put that in the uh, what do you call Keystone or Murano uh, catalog. So the different catalogs you can use. The Glance is also a catalog, but you can define your private catalog or public catalog. You can pull them, and then you can run the instantiate those containerized versions of OpenStack as a integrated or distributed. Either way, if you do integrated, it'll be easy. Now, does it mean it can support everything? Yeah, if you use Magnum, you can use Magnum based also, which is an orchestration engine which uses heat. So Magnum based also you can do. So there are different ways of doing development and production. Then the question is, how do you maintain it? So CI/CD is important. There are several CI/CD modules available in OpenStack, and you can use the Zool or you can use the Jenkins. And so if you do a CI/CD way of or a DevOps way of implementation of OpenStack, they can not only you can develop, you can build and deploy in a distributed way in different sites and be able to maintain it. So day one, day two operation both are covered with that. So that would be my answer. Is that good
Yes,
enough?
definitely. Yes, yes, Prakash. So the next question is how justifiable it is for the big companies to embrace public cloud for their operations.
So big companies is enterprise multinationals. They already are using public cloud. Most of them. Okay, I wouldn't say all of them, but most of them. The reason you have a capex versus opex here. So do you want to spend on the capital or do you want to spend on the operation? And can you minimize on capex? Because of course capex is something it goes into balance sheet. So you got an asset, you can take a what you call depreciation on that. That's one part of it on the balance sheet if you look. So that way some enterprises yes want to capitalize, so they use it for research and development. So whenever there is a availability of R&D to capitalize, they will use it. But most of them still run on thin cash. To run for a payroll, for they have to borrow sometime or most of the time if you are a big enough with 100,000 people and all. So because the money matters here, so therefore would you do capex or would you do apex? CFOs of the organizations force people to use the public cloud because then you pay as you go. But pay as you go, if it becomes you pay more, then it is not worth it. You pay less, it is worth it because then the bottom line is justified. So it's a more economic issue than capability. Capability is available right through. You can go from one to another. Yes, there are technical gotchas, like you may not be able to port certain thing properly, so you'll have to uh, evaluate that. So technical folks can evaluate and identify whether how to do capex, opex, and then operation management, DevOps, and all that. But it's more of a uh, necessity for the CFOs, especially in COVID-19. Now, most of us are doing remote, you can see. So, public cloud usage is very normal.
Thank you, Prakash. Thank you for that answer. So, as we are on top of time, we would be taking one last question, and that would be like, as you have very well explained during your session, the journey from bare metal virtualization to the VMs and now the era of containerization. So, how do you think the telcos of the world would be embracing this, and in really in view of the 5G picking up? So, how good or bad, or how easy or difficult it would be the telcos of the world to embrace it? As you have rightly mentioned, they have to juggle between the capex and opex, and now they have this OpenStack running most of their virtualized environment. How easy or difficult it would be to embrace this containerization moving forward for their virtualization journey?
So, the answer to that is uh, time to market. Uh, you do not have what you call sufficient time to deliver because the competition is severe. So, most of the time, what is happening is how do I quickly get the work of hardware done? Can I get a cloud immediate? So the necessity for speeding up has brought in automation, DevOps, and then need for AI and ML to expedite the inferencing. All this is pushing everybody, including uh, 5G applications, edge applications. All these require what you call end-to-end capability available globally across geographies, across zones, across regions, and be able to leverage the market. If you have anything new market available or COVID-19 market, right now people are looking at can I do some capabilities that will help reduce the risks associated with drug discovery, risk associated with uh, what you call the uh, educating the people, uh, be able to block the spread of the virus. So these are the challenges which companies face, and they are real life. It's not um, just coding, so it is beyond coding. You can say infrastructure as a service or a cloud as a service, cloud native service. Uh, these are concepts, but reality is you need to drive to be able to leverage and deliver. Example, if everybody is at home, how do you deliver the training to people, training to kids? Do you use a Chromebook? Do you have everybody capability to deliver that? And is that sufficient? So essentially what boils down to is how do we address the emergence of newer technology and integrate into practical life. So 5G, if you want a radio unit, a distributed unit, and then the front end, front hall, back hall, do we have the capability to run the fiber optics to be able to do the what do you call the capacity to manage as the load increases because of everybody is going digital. So digital transformation eventually leads to need of more infrastructure, and not only node differentiated infrastructure, and how fast can we deliver it. So besides the capex and opex, the time to market to be able to be revenue producing and be able to feed the employees, and if not, even if you are a business, how do you innovate to achieve in this 5G era? So we have to reach beyond 5G. Yes, what can we do? what are the various applications that are required to be hosted or to be in the cloud, and that's the key. So essentially, simple answer is we are going to evolve no matter what, and whoever is able to do it faster and cheaper and reliable with security, they are going to win. So open source is the way to manage, and technologies will keep come and go. Some technologies will succeed, some will fail. 5G is definitely there to stay, and we expect that it will ramp up the use of the edge. It will start with the edge. Right now, it is going through edge and IoTs because devices are massive. You are going to have billions and billions of devices. We do expect that this is going to lead to a transformation, a digital transformation, and which is already on way. And it's you cannot run away from it. You have to embrace it.
Yeah, so basically survival of the fittest while we are embracing the open source technologies.
Sure.
Okay,
That is
so
going
there
to
are,
be there.
yeah, so there are many questions on use case white papers. I am just like typing the URL in the chat window. So the place you need to look is docs.openstack.org, and I presume the current version is named as Tray. So all the people who are interested in taking a look at the documents, docs.openstack.org is the link that you need to refer to. So this with this, like I would be requesting Puneet sir, Chair IEEE Bangalore section, to have the final words so that we can wrap up with this today's presentation.
Thank you, Chengappa, for inviting me. First of all, I would like to thank our today's experts, uh, Prakash, for delivering an insightful webinar on OpenStacks. And I like the four opens of OpenStack in the last slide, which he has written: open source, open design, open development, and open community. Those are the real thing if we can adopt. And you may be aware that IEEE is known for open platform and open promoting open source code and other things. So it will really help not only us but the entire community and world. So thank you for sparing your time, expertise, and experience with us. And I would also like to thank on behalf of Bangalore section for your all the effort which you have put in preparing slide and sparing your time. I know in US it is morning, still you are with us. Along with me, along with you, I will also thank all the attendees. You can see till end they are there and they are asking questions. Still few questions are left.
You
So
can mail me all the questions. I will answer them through
yeah,
mail.
thank you very
Anytime.
much. And hopefully we will have honor to have you again in our Bangalore Technology Conclave, which is happening in October. Thank you very much.
Thank you very much for that, IEEE, to provide me the opportunity. And I would pitch one for the CCICI for the interoperability work. They have been doing great, and like to see them present in future in some organization, similar presentations. Thank you.
Yeah, thank you all. So we will meet you again tomorrow 8 p.m. with new expert, new topic. Thank you very much.